In this section, we are going to cover section 5.1, which is angles and radian measure. A lot of very basic information, however necessary to fully comprehend the chapter. As though they begin with describing what the terminal side is of a triangle. In this case, when we have two adjoining vectors, you have what they refer to as the initial side, which is actually this side here in blue. This is what they refer to as, again, the initial side. And we talk about a triangle with a terminal side. This is its terminal side in red. All right, and so the vertex, we'll call this or label it point B, where the two vertex meet, or rays meet, excuse me. In this case, we call this a triangle or an angle in standard position. Also understand that this is an angle, two rays with a common endpoint, basically. They're referring to this as standard position. So be careful with clockwise versus counterclockwise, because that makes a difference as to how we perceive the angle direction to be. And so the next thing that they do talk about that is of importance is a quadrantal angle. This is just informational background. Quadrantal angles, in essence, if you're looking at a coordinate plane, and let's say hypothetically you've got an angle, which we refer to quadrantal angles as beta. So if you ever see an angle referred to as beta ending at one of the quadrant sites, such as this one, this is what we call quadrantal. So let me spell that out for you. Quadrantal angle. All right. Same thing would apply for a terminal side angle if we were looking at the angle in a quadrant. So let's talk about that for a minute. So if I have an angle that is opening up with the initial side sitting at the x-axis, so let's go with this as the initial side of the ray. Here's your obviously vertex, and let's say hypothetically this opens up in this direction. Okay, this is referred to as alpha. So the initial side along, it's opening up obviously in this direction. On the opposite direction, if you have an angle opening up in a negative direction, so let's say this is, again, going back to this basic drawing where this is the initial side, but this time this angle is going to open up in this direction. So let's say it gives you a terminal side over here. We will refer to this as a negative angle, and that's theta. All right. The other thing when we talk about this concept, we also talk about the radian measure. So I want you to remember that in this case, if I'm looking at 1 radian, so let's say hypothetically I'm looking at a circle, and the circle happens to be facing in this direction with these two rays. 1 radian, remember this is the initial side, this is the terminal side, and this angle is opening in this direction. Remember that this is creating 2 radii, and this is the definition of 1 radian. So you have 2 radii that are sitting in the circle, and this is also referred to as the radian measure. And basically, for 1 radian angle, the intercepted arc and the radius are equal. So notice that these are all the same in the sense notated. They are all r, indicating they are all equal. So when we talk about 1 radian, this is a crucial part to understand in terms of the ratios. You do have other information we need here. So let me talk to you about radian measure and go to example 1. So in radian measure, we're looking again at a circle. Let's use the same circle I have up here. I'm just going to erase these pieces. Oh, wonderful. I just erased everything. All right, so let's go back to our circle. Here's the center of our circle. You have the initial side, which is always going to be sticking out this way in this case. You have another side sticking out this way. This is the terminal side. And in this case, our angle is theta opening up this way. And you have an arc length. This arc length in red. That's your, let's call it S. So these radian or radii that are sitting here basically give us this formula where theta, this theta, is going to equal the value of the arc length over r radians. So let me give you an example of what that looks like as a question. So let's say that this arc length is 16 or 15 inches. So let's go with 15 inches. And let's say that this radii in this case is 6 inches. So this is 6, this is 6. So in essence, this is going to become theta, equivalent in radians, is equal to 15 over 6, which is equal to approximately 2.5 radian. When we refer to a rotation, I want you to remember that in one rotation, you have this arc length, and this is just a no piece of information. In one rotation, we're going to look at that arc length is equal to twice pi times radian. Okay, and so remember in this case, that means that 360 degrees is equal to 2 pi radian. It's radian. Obviously, if I'm looking at 180 degrees, we refer to that as pi radian. Again, we're just sort of establishing some code for communication. By the way, this was example 1 in the textbook. I just wanted to flow with the question or the concept. Now, you should be able to convert between degrees and radians. We're going to talk about that next. This is example 2. For some of you, this is extremely basic information. But for those seeing this for the first time, it's quick to learn. So you're converting from degree to radian. Degree to radian. So they want us to convert in part A. If they're giving us 30 degrees. When we do this, it's very simple. What we're going to do is we're going to multiply by pi over 180 degrees. This then becomes 30 degrees pi over 180 degrees phi, which reduces. 30 goes into 31 times and into 186 times, and we end up with pi over 6 radian. Same thing for the second and third examples. So for part B, if we have 90 degrees, now this one is important because this is a measure that is standard to us, which, by the way, please learn the unit circle, learn all its values, all its angles. Understanding the unit circle is the key to this class. Actually, I could stop teaching this entire curriculum and just focus on the unit circle, and we'll cover the entire chapter. So once again, we're converting the 90 degrees from degree to radian. So we're going to multiply by pi over 180 degrees, and we end up with pi over 2 radian. Okay, pi over 2 is one of those standard values that we use in the unit circle. Okay, in part C, they're giving us negative 135 degrees. Remember, I stated that if you go counterclockwise, that you're basically graphing negative. So again, same thing, times pi over 180. You end up with negative 135 pi over 180, which then reduces to, and remember this is radian, this reduces to negative 3 over 4 pi radian. So that should be fairly easy for you to comprehend. Example 3. This time we're converting from radian to degree. And in this case, what they're going to give you is, for example, pi over 3 radian. And again, we're going from radian to degrees. So what you're going to do is you're going to multiply this by 180 over pi. What happens is the pi's will cancel. And now you're converting to degrees, because now you have 180 degrees divided by 3, which is basically 60 degrees. And that's the key to this particular example. For part B, they give you a negative 5 pi over 3 radian. And again, you will multiply by 180 degrees over pi. Always have the pi's opposite each other when you're converting. Always have 180 over pi. See how the pi's will cancel? That leaves you with negative 5 over 3 times 180 degrees, which becomes negative 300 degrees. So you have a counterclockwise movement on this particular angle if you were graphing it. So you start with your initial side. So let's start on the initial side right here. And we're moving in this direction. So that's 90, 180, and here's 270. 270 and a little bit more, let's say here. And there's our terminal side. And that's what your 300 degree angle, negative 300 degree angle should look like. Okay, and part C. In part C, we have basically 1 radian. which, by the way, is another measure you should sort of memorize, which is equal to basically 57.3 degrees, and that's a rounded value. How you obtain this, again, if you have 1 radian, you're going to multiply it times 180 degrees over pi. So in essence, 180 divided by pi is going to give you 57.3 degrees, which is the equivalent value of 1 radian. That is a memorization piece. If I have 2.3 radian, what I'm going to do again is I'm going to do the same thing. I'm going to multiply by 180 degrees over pi. And this will end up being 2.3 times 180 degrees divided by pi. And the equivalent angle value is 131.8 degrees. So that's examples 1, 2, and 3 in a nutshell. The next example is simply discussing drawing angles in standard position. And prior to that, they do talk about what 1 revolution looks like, what two revolutions, and so on. So let's go ahead and discuss that anyway, because I think that is important to know. So if I have 1 revolution, in essence, I am going fully around, obviously, the quadrant, right? With my initial side being here. My initial side, I'm going in this direction, 1 full rotation. We refer to 1 revolution as 2 pi radian, and the equivalent degrees 360 degrees. If I have a quarter revolution, a 3/4 revolution, remember 3/4 revolution, I start here, that's 1, 2, and I stop here. So I will stop at my terminal side in red, which is 270 degrees. Remember, if I have 3/4 times 2 pi, because you're basically going to multiply 3/4 times 2 pi, you're going to end up with 3 pi over 2, which is the equivalent value of 270 degrees. The initial one I did was 360 degrees. Okay, a half a revolution. Let's go ahead and do that here. If I have a half a revolution in green, I'm stopping here in the green arrow. This is 1/2 revolution, which 1/2 times 2 pi puts me at pi, which was what this value is here. This one is, what did I say, 3/2 pi, and this one was 2 pi. And we did discuss the 1/4 revolution. In the 1/4 revolution, we're dealing with the purple, where we end here at 90 degrees, and that's this terminal side here. And that's 1/4 a rev, which basically 1/4 times 2 pi results in pi over 2. And remember, I stated that was one of those must memorize. So this is your pi over 2. Again, learn that unit circle. So they just review that with you momentarily. In example 4, we're going to draw some more. We're going to draw angles in standard position. Now, much of this knowledge is so simple. You just learn it. You just see it once. That's usually all it takes. Okay, so they're going to ask us in part A. They want us to draw where theta is equal to pi over 4. And so in this case, I need you to remember a couple of things. Pi over 4, which we know is a 45-degree angle, talk about memorization, this is always going to be your 45-degree angle. What I want you to do is think about, if I have pi over 4 radian, I multiplied this by 180 over pi. Notice that the pi's are simply going to cancel. And you're left now with 180 degrees divided by 4, which is in essence 45-degree angle. If I'm drawing this angle and it's a standard position, all right, that means that this is my initial side here. Obviously my vertex is the origin. I'm coming up halfway through the diagram of the first quadrant, and that should be about the value that we're looking at. This is where theta is 45 degrees. If we were to do the next one, part B, they give us a value where we have alpha. I always draw alpha, it looks kind of like a little fish. This is equal to 5 pi over 4. So I want you to think about this for a moment. Well, since we started with pi over 4, which is in essence a fourth of the quadrants, right? So this is 1/4. Here's the other fourth. If I split this in half, technically this is the 3rd fourth. This is the 4th fourth. 4/4 I'm at pi, right? This is 5 pi over 4, so guess what? This should end right here. Notice that I'm counting out 1/4. So I have 1, 2, 3, 4, and 5. 5/4. Now, let's logically stop for a minute and make sense of this, of what I just said. Each of these is basically, or each quadrant is basically 8 of these. If I were to keep counting, we're 5, 6, 7, and 8. So every quadrant can be split up into 8 quadrants, basically, or 8 parts, right? If I were to multiply this by 180 over pi, I want you to notice, again, just mathematically, that cancels. You know that 4 goes into an 80 45 times, and we have 5 of those. Hence, 45, this is 45, this is 45, this is 45, so is this. So 5 times 180 divided by 4 tells us that in this case we have basically 180 plus 45. So in reality, this angle measure should be 225, right? So that seems like a fairly easy lesson, I would assume. This entire angle, all of it, all the way over, would be equivalent to 225 degrees. All right. And so this is just understanding that we're looking at 5/8 of the circle as a ratio. Okay, let's look at part C. In part C, I've got angle beta is equal to -3 over 4 pi. So if I'm drawing this out, just doing reasoning, just reasoning out that, you know, I could take a quadrant coordinate system and split it up into 8ths, basically. So if I draw a line across here, and I draw a line exactly in half, splitting this up. In this example, I am going -3 over 4. So -3 over 4. So I'm going to go 1, 2, 3. And the angle that I'm looking at is right here. this being its terminal side. So let me do that in red because I've been consistently doing that in red. With this vertex and the initial side in the blue. So if I did this again using -3/4 pi times 180 over pi, notice that the pi's again will cancel. 4 goes into 180 45 times, and I'm left with 3 times. Remember, that's 45 degrees. I'm left with -3 times 45. So my angle measure in this case should be 135 going this way. So all of this from here to here is 135 degrees. And it is a negative angle. Now they have two methods that they use. So I'm going to introduce this with part B real quick. So method 1, they take the 5 pi over 4 and they say that this is equivalent to 5 over 8 times 2 pi. That's method 1. If you look at the math behind that, this will reduce to 5 over 4, 5 pi over 4, basically. Method 2, they take 5 pi over 4, and they say that this is equivalent to pi plus pi over 4. And looking at the diagram, that's kind of what is being insinuated anyway. So either way, it works. Whichever one makes more sense to you is the one you should go with. They both work. I like just looking at it in eighths. It just seems to be as if you're just counting down parts, which, I mean, that's elementary, I think. Let's do the same thing with this one, with the 3/4. So you have, ignore the negative, we look at the absolute value of it. So we look at 3 over 4 pi, and we say that this is equivalent to 3 over 8 times 2 pi. So it's notice that what I'm saying is true. It's 3/8. You're looking at 1, 2, 3/8. Remember, I am splitting this into 5, 6, 7, 8. So I'm looking at 3/8 of the entire circle. Method 2 is they take the 3 pi over 4 and they say this is equivalent to 2 pi over 4 plus pi over 4, which is equivalent to 90 degrees, hence pi over 2 plus pi over 4. In a sense, isn't that the same thing we have drawn here? Because this is technically 90 degrees here. There's your pi over 2. And then we have this little slither that's sitting here. That's your pi over 4. So they're just justifying it one way or another with just taking a diagram and making sense of what was given to you. Okay, here's part D. In part D, they give us gamma equal to 9 pi over 4. And same thing applies in this case. We're going to take the 9 pi over 4. Remember, this is the equivalent of 9 over 8 times 2 pi. Again, the reasoning is that 2 pi and the 8 will simplify to the 4. At least that's a theory. Which in itself, this actually is the equivalent of 1 rotation over the whole, if you think about it. It's basically 1 1/8. This gives you 18 pi over 8. If I were to simplify this, divide by 2, I would get 9 over 4 again. 9 over 4 pi. I could also think of this mathematically with division and just simply say, well, 8 goes into 18 twice. That's a full rotation. And I have 1 rotation left over. I have 2 over 8 left over, which is a quarter. So if I'm looking at this, think about it. I'm starting on the initial side. I'm going to go 1 full rotation and a quarter. I'm here. So in essence, it's 180, 360 degrees plus 45 degrees. If you add these up, you get 405 degrees, which is what the equivalent of this angle is. By method 2, you would have taken 9 pi over 4, which is equivalent to 2 pi plus the pi over 4. I think this is what I verbalized here, in the sense of 1, 2, 3, 4. There is a split. 5, 6, 7, 8, and here's your 9th turn, in a sense. Okay, so that's example 4. I also want to talk to you about coterminal angles next. Okay, so in coterminal angles, what is a coterminal angle, first of all? And let's talk about this with some examples. In this example, what I want to do is just go ahead and jump into example 5, and I will discuss with you how to find coterminal angles. So in the first question, they want us to assume, first of all, that these are in standard position. And they want us to find a positive angle less than 360 given a 420 degree angle for part A. So what we're going to do is we're basically going to subtract 360 degrees. And that gives us 60 degrees. And that means that 60 degrees is coterminal based on those criteria. So a 60 degree angle is coterminal with a 420 degree angle. In part B, they give us a negative 120 degree angle, and they ask us to do the same thing. And so since it's a negative, I'm going to add 360 degrees, and that puts me at 240 degrees. And therefore, in this case, 240 degrees is coterminal with negative 120 degree angle. And if we were to draw it, basically what we're looking with coterminal angles is the direction of the movement. So if I go clockwise versus counterclockwise, I'm going to end up in the same position. So for example, if I have a 420 degree angle, as in part A, so that's your 420 degree. In essence, this angle that coincides here, from here to here, that's 60 degrees. And that's what we're referring to. Same terminal side. Same thing applies to the second example. And in the second example, I have a negative 120 degree angle. So it's coming from the initial side this way. That's the terminal side. Here's your initial side. And you're looking at 120 degrees. And if I go the other direction, if I go this direction up to here, this is now 240 degrees. So no matter which way you approach it, you're going to end up wherever you began. Now, be careful when you do your homework in Pearson that you follow the directions given to you. Okay, example 6, we're doing the same thing, but this time our measures are in radian. We're finding coterminal angles, nothing changed. And I urge you to explore this. Just when you do your homework, take your time on it, draw your pictures. Let me start with side A. Start with 17 pi over 6. They say assume the following angles are in standard position. Find a positive angle less than 2 pi that is coterminal with each of the following. So in this one, I want you to understand that if you take 17 and divide it by 6, 6 goes into 17 twice, we're with a remainder of 5 over 6. In this case, if I take 17 pi over 6 and I subtract 2 pi, remember this is 2 pi over 1, so I have to multiply by 6 top and bottom to get a common denominator. So now I have here 12 pi over 6, and this is equal to 5 over 6 pi, or 5 pi over 6. And so the result is that 5 pi over 6 is coterminal with 17 pi over 6. Now let's just stop for a moment for the sake of exploring. And let's convert this to degrees so we know what we're talking about in terms of angles. So this will cancel. 6 goes into 180, obviously 30 times. And 17 times 3 will give us 51. So this is a 510 degree angle. Okay, so that means that if I'm drawing this, I'm going around the circle twice and then 5/6 with a remainder of 1/6. So if I do the same thing with 5 pi over 6, and I'll multiply by 180 over pi, this is just exploring. There's nothing wrong with that, and I know this may seem mundane to some of you. Notice that 6 goes into 180 again 30 times, and 5 times 30 gives you 150. So if I'm looking at the direction of what this is implying, all right, so here we are. Starting with the initial side, let's start with the small one. Let's start with the 150. Obviously this is 90, and 150 is going to be somewhere about here, leaving me 30 degrees unused. Here's the 150. According to the second angle, or the first angle given to us, that's 510 degrees. So if I take 510 degrees and let's go around the circle one time, that's 360. So ask yourself, 360 plus what will give me 510? and obviously the answer is 150, and we're back to our terminal side here, and all of the purple is your 510 degrees. So that is in essence what you've done. So I just wanted to put 2 and 2 together so you see where the connection is. Remember, 1 full rotation is 2 pi. And in this case, we did have 1 full rotation. Let's look at example B. In example B, we are given a radian measure of negative pi over 12. Just keep in mind we're trying to find a positive angle less than 2 pi that is coterminal with respect to this angle. And so in this first case, if I'm going negative, I'm going to actually add 2 pi to this. Remember, that's 2 pi over 1. So this is really negative pi over 12 plus 24 pi over 12, which is the equivalent of 23 pi over 12, which, let's do some math. Let's talk math. If this were 24, doesn't 12 go into 24 exactly twice? So that would be a full rotation. I'm just 1/12 shy of that 24. So let's assume we're splitting the quadrants up into 12ths. Whatever sliver this would represent, this would be the equivalent of negative pi over 12, right? And so if a full rotation or a 3/4 23 over 12 would be falling here as well, is what I'm getting at. So there's your 1/12 rotation, again, completed. All right. Let's look at example 7. We're still dealing with the same coterminal angles. This one does change a little bit. This one says find a positive angle less than 360 or 2 pi radian that is coterminal with each of the following, and they're giving us some pretty large angles. So we're going to start with this one, which they give us 750 degrees. So if I begin with 750 degrees, what I'm going to do is, notice that I'm going to take away 360. And I technically already know mentally that I could do that twice. Because 360 times 2 is 720, and I obviously know that if I take out another 360, what I really have in total is 750 degrees minus 720 degrees, which gives us 30 degrees. So the 30-degree angle is coterminal with the 750-degree angle. Again, you draw the picture. It's the whole discussion that we've had about ending up in the same spot, basically. Okay, the next question they give us about coterminal angles, we have 22 pi over 3. Now, I want you to stop and think for a second. In this case, how many times would 3 go into 22? So it goes in 7. So if I took 22 and if I divided by 3, I get 7 1/3. So that tells me that if I subtract 3 multiples of 2 pi, or the equivalent of 6 pi, I should find that coterminal angle. Look at it this way. Here's 22 pi over 3. If I take away 2 pi over 1, I would have to repeat this at least 3 more times. So in essence, multiply by 3, all of this becomes 6 pi over 1. So you really have, if this is 6 pi over 1, common denominator, multiply by 3 on top and bottom. Now you have 22 pi minus 18 pi over 3, which leaves us 4 pi over 3. So 4 pi over 3 is coterminal with 22 pi over 3. Let's look at part C. I have negative 17 pi over 6. If I take 17 and divide it by 6, I end up with 2 and 5 over 6. Technically, if I look at this from a math perspective, what I'm going to do is I'm going to add 4 pi, basically. In other words, 2 pi times 2, which this gives me 4 pi, technically over 1. If I get a common denominator and multiply by 6 top and bottom, this is going to become negative 17 pi over 6 plus 24 pi over 6, which is going to leave me 7 pi over 6. So what is coterminal? 7 pi over 6 is coterminal with, or coterminal to negative 17 pi over 6. Okay, in part D, they're giving us negative 10.3 as a value. In this case, if you remember, 57.3 degrees is equivalent to 1 radian. So all you have to do is basically multiply by 57 degrees and you get negative 587.1 degrees, and that is coterminal. If you do this with radian, you have negative 10.3 plus 2 pi times 2, which is the equivalent of 4 pi. So if I have 10.3 plus 4 pi, this is the equivalent of 2.3. So that's another approach. Okay, we're almost done. Hopefully the system will record this without issue. They do give us one more concept with respect to arc length. And if I'm looking at the arc, let's say that this sector goes from here to here. I have obviously my initial side and my terminal side, and this being theta, where S is the arc length. There's one more formula, and that is the length of a circular arc, where S is equal to the radius times theta. And this brings us to example 8. In example 8, they tell us that a circle has a radius equal to 10 inches. They want us to find the length of the arc intercepted by a central angle of 120 degrees. Okay, and so first things first, always remember we want to change the angle measured to radian. So let's take the 120 degrees, let's multiply it by pi over 180 degrees. And in doing so, we end up with sorry, my pen's not reacting. I don't know what's going on.